Welcome to the lecture number 43 of fuzzy sets, logic and systems and applications. In this lecture, we will discuss the concentration and dilation of fuzzy sets, and also we will discuss a composite linguistic terms and the related examples. So, here let us first have the concentration and then the dilation. Concentration basically is nothing but it is actually the concentration of a fuzzy set, and when we say fuzzy sets, it means that we have some linguistic value and which is characterized by a fuzzy set or which is represented by a fuzzy set. Let us say A, then of course, we will have its membership value or membership function in case of continuous linguistic value. So, we will have mu A of x. In case of x, we have the generic variable. So, if let us say we have A which is a linguistic value, and when we say linguistic value, it means in fuzzy system we represents a linguistic value by a suitable fuzzy set. So, we can say that it is nothing but a suitable fuzzy set. So, if we have a linguistic value which is represented by a suitable fuzzy set A, and if we are interested in having the concentration of a fuzzy set A, so this concentration of fuzzy set is nothing but A of k. So, concentration of a fuzzy set A is normally represented by here A raised to the power within bracket k, and if it is a continuous fuzzy set which is being concentrated, then of course, this will be represented by the integral sign, and then we have the universe of discourse capital X, and then we have mu A of x, and since we have the A of k, so this k will be here as well. So, this way the concentration of A is represented by the expression A of k, A raised to the power within bracket k, and similarly if we have a discrete fuzzy set which is being concentrated, we will use sigma, and then we use again the suitable universe of discourse. So, in this case we have the universe of discourse as capital X. So, for continuous and discrete fuzzy sets, we have the concentrated versions of these, the concentrated fuzzy sets. So, in summary, a concentration of any fuzzy set basically is nothing but we get another set which has its membership values or its membership functions raised to the power k. So, rest other things remains the same, which we can see here that we simply raise the power of membership function in case of continuous fuzzy set, and we raise the power of membership values in case of discrete fuzzy sets. And as I mentioned, rest other things will remain the same. So, here as I mentioned, the power of membership function is raised by k. So, k is here some number. In general, we write k for concentration, but for normal concentration are mentioned here that when we do not mention any value of k, then normally for simpler concentration the value of k can be 2, and the value of can be any value more than 1. So, if nothing has been mentioned, then we can simply write the value, we can take the value of k as 2. So, when we take a normal concentration, we have here, we have taken k is equal to 2, and when we substitute the k is equal to 2, what we are getting is here for continuous membership concentration. So, if we have a fuzzy set A, which is a continuous fuzzy set, and if we are interested in finding the concentration of fuzzy set A, then we simply write here A raised to the power 2 within bracket. Why within bracket? Because we are not exactly squaring the fuzzy set A, we are only squaring here the membership values or membership functions of the fuzzy set A. So, here this way this A raised to the power 2 within bracket is equal to the integration sign, and then we have the universe of discourse and mu A of x raised to the power 2 oblique x. So, this is going to be our concentrated fuzzy set. And when we have a discrete fuzzy set, so for discrete fuzzy set everything remain the same except the summation in place of the integration sign. So, this way we have understood that what is a concentration of a fuzzy set. So, once again I would like to tell you that if we are interested in finding the concentration of any fuzzy set, we will simply write the fuzzy set and we will try to find the value of k. If the value of k is given here, the when we are interested in concentration, the value of k will always be greater than 1. This has to be noted for concentration. So, we will first look for the value of k, and if the value of k has been given, then we will use the value of k which will be more than 1. So, we will use that, but if the value of k is not mentioned, then we will go for the normal concentration, means we will take the value of k as 2. So, as we have done here. So, concentration is very simple, and we simply use the value of k which is more than 1, and this value of k basically increases the power of the membership function for continuous fuzzy set or the power of membership value for discrete fuzzy sets. And here the notion of this concentration is nothing but when we concentrate any fuzzy set, whatever fuzzy set that we have, here let us say we have a fuzzy set A, let us say this is a fuzzy set A, and if we are interested in concentrating this fuzzy set, so this the concentrated fuzzy set will be something like this. depending upon the value of k. So, I can say this is my concentrated discrete fuzzy set. So, I can write here that this is a concentrated fuzzy set A. So, what do we see here? What basically do we see here is that when we go for the resulting fuzzy set, that is a concentrated fuzzy set, gets squeezed, means the spread gets reduced. So, that needs to be understood here, that whenever we concentrate any fuzzy set, its spread is going to get reduced. Let us take couple of examples on the concentration of fuzzy sets to understand the concept better. So, here we have a simple discrete fuzzy set A, a discrete fuzzy set A with the universe of discourse 1 to 5, and here we are interested in the concentration of A, and K has not been given to us. So, obviously, we will have to go for the value of K is equal to 2. So, I am writing here, since the value of K is not given, so we will go for the normal concentration, and this means we would take the value of K is equal to 2. So, when we do this here, the concentration of a discrete fuzzy set A, this can be written as this equation. So, A raised to the power within bracket 2 is equal to summation over the universe of discourse capital X mu A of x raised to the power 2. So, the K comes here, K is equal to 2. So, the membership values of this discrete fuzzy set will get squared. So, when we go ahead, we write the symbol of the concentration as CON. So, concentration of A basically is equal to the summation over x, which is the universe of discourse, and then mu A of x raised to power 2 oblique x, and this is going to be equal to 0.1 raised to the power 2 oblique 2 plus 0.7 raised to the power 2 oblique 3 plus 0.8 raised to the power 2 oblique 4 plus 1 raised to the power 2 oblique 5. So, we are doing nothing except we are squaring the membership values of the corresponding generic values of x. So, when we are squaring this, what we are getting? We see here that we are getting 0.01 here when we square 0.1, and we are getting 0.49 when we square 0.7, we are getting 0.64 when we square 0.8, and we are getting 1 when we square 1. So, this way we are getting a new expression of the discrete fuzzy set, which is here corresponding to the generic variable values. We are getting the modified values of the membership. So, we get the concentration of the fuzzy set which we have taken as a discrete fuzzy set. So, we can write here the concentration of A is nothing but 0.01 oblique 2, then 0.49 oblique 3, then 0.64 oblique 4, then 1 oblique 5. So, this is what is the new fuzzy set as a result of the concentration of the discrete fuzzy set that was given to us. All right. So, this was the example for the discrete fuzzy set, or I would say the concentration of discrete fuzzy set. Now, let us take another example for the concentration of a continuous fuzzy set. So, if we have a linguistic term which is defined by a suitable fuzzy set, let us say it is named as a bright. So, fuzzy set for bright. So, bright is a fuzzy set, bright is represented by a suitable continuous fuzzy set, and the universe of discourse here is from 0 to 50. So, I can write here linguistic term bright is represented by a suitable fuzzy set here, where the membership of this bright fuzzy set is represented by mu bright of x here, and this is nothing but a Gaussian function. So, this is represented by Gaussian x semicolon 20 comma 5, and this is nothing but the exponential of minus 1 by 2 into x minus 20 by 5 whole raised to the power 2, where this 5 is nothing but the standard deviation. And this 20 is nothing but the mean. So, this is the standard deviation, and this 20 is the mean. Now, here we have been asked to concentrate this fuzzy set bright, and bright is a continuous fuzzy set. So, let us do that. So, we will write the concentration of bright fuzzy set by the cons of bright, the concentration, we will write concentration and then we will write bright like this. So, when we do this, let us first take this fuzzy set which has been given to us. Let us first understand the continuous fuzzy set, that is for the linguistic term bright. So, when we plot the fuzzy set here, the bright fuzzy set, this looks like this, and this is nothing but the Gaussian membership function. So, we have the fuzzy set which is for bright, and this bright has the membership function as the Gaussian with its mean 20 and its standard deviation 5, you can see here. is 20. So, we can represent the bright fuzzy set like this. Now, let us concentrate this fuzzy set bright, and as I already mentioned that we can write the con of bright, means the concentration of bright like this, and this can also be written as bright raised to the power within bracket 2, and then this is again going to be equal to, since this is a continuous fuzzy set. So, we will use the integral sign to represent this fuzzy set. So, integral sign over capital X, which is the universe of discourse, and then we will write the mu bright of x raised to the power 2. Here this power 2 comes because we have the normal concentration, which is k is equal to 2 and then oblique x. So, initially for bright we had simply the mu bright of x, but when we are concentrating the fuzzy set bright, then we will have to raise the power of the membership function by k, and k since is not given in this example. So, we can take k is equal to 2. If k has been given, then we will use the same value of k, and this k, since we are concentrating the fuzzy set, so the value of k is going to be always more than 1. So, here we are taking k is equal to 2, we are squaring the membership function. So, when we do that, the whole fuzzy set can be written as the integration sign x and then within bracket the membership function, which is e raised to the power 1 by 2 into x minus 20 over 5 raised to the power whole raised to the power 2, and then again whatever is here as the membership function is squared, means raised to the power 2, and then we have the oblique x. So, this is con bright again, or in other words we can write here the bright and then within bracket 2, and here please note that we have used k is equal to 2 only, we have used the small k is equal to 2. So, let us not get confused with the value of k. As I have already mentioned, if no value of k has been given, then we will simply use the value of k as 2 for concentration. So, when we plot the concentration of bright, means the fuzzy set which has come out of the concentration of bright, we get this fuzzy set. So, which is represented by the red color here. So, this fuzzy set is the concentration of bright. I can write it either this way or the con bright, and this blue plot is for the bright fuzzy set. So, we can clearly see that when we concentrate any fuzzy set, we get its spread reduced or squeezed. So, here if we once again go for further concentration of the concentrated bright fuzzy set, we will further get the spread reduced. So, here the concentration basically helps us in reducing the fuzziness, the uncertainties that is involved in the fuzzy representation. So, concentration of any fuzzy set basically gives us a reduced spread than that of the original spread of the fuzzy set that was taken for concentration. So, with this the discussion on the concentration of a fuzzy set is over, and in the next lecture we will discuss the dilation and the composite linguistic terms with some suitable examples. Thank you.